Hi guys, welcome back to Calculus. This is Mr. Robeson. We're going to continue our trend with more derivative rules coming soon, but first we're going to review inverse trig functions. So like the arc trig functions, arc sine, arc cosine, arc tangent, all that sort of stuff. So that's what we're doing first. Then the next video will be how do we do derivatives with all of them. All right, so first up, boy, there's a lot of writing on here. So there's multiple ways we can do this, and there's multiple ways we can write this. So if we have something written like this, like y equals the arc sine of x, means to find the angle y whose sine is equal to x. All right. So sine of the angle y is equal to the sides opposite over hypotenuse here, x. All right. So it's working backwards to find angles. So this is our angle that we're getting. And this is our side ratio. Hopefully you remember this from PreCalc or somewhere else where you've went over arc trig functions. All right, and all of them are the same thing. They're all just working backwards from the side ratio to get back to the angle. Now they all have different domains. All right, so like sine and cosine, they go back and forth between -1 and 1. So the domain for these guys is -1 to 1. Tangent and cotangent, they both go off to infinity, so they can be anything. Secant and cosecant, remember those graphs look like they're on top and bottom of the tangent graph, so they look like that. So they never hit anything between -1 and 1, so they have to be greater than 1 in absolute value or less than -1. All right, when we go back to what angle we're talking about, all of them go back to different quadrants. But the easiest thing to remember is if it's positive, it's going to the first quadrant. If it's negative, it's going to the closest quadrant we can find. All right. So remember, all students take calculus. So like sine's negative here, so that means the negative sign is going back to the fourth quadrant, closest to the first quadrant. All right. The one that's tricky is tangent. All right, because tangent's negative in both of these. Right, so really you can go back to either one. But tangent, they want you to go back to the fourth quadrant. And cotangent, they want you to go to the second quadrant. All right, it's just kind of weird. I don't know how to keep that one straight myself. But luckily those probably won't come up. And on the AP exam, if you get to the point where your answer is arctan of 7, you can just leave it like that. All right. So here's graphs of all those inverse trig functions. Really, I think the only one you might need to know is the graph of arctan. It has these horizontal asymptotes at y equals pi over 2 and at y equals -pi over 2. I have seen that come up on the AP exam. I don't think I've seen any other ones come up really on the AP exam, but they are good to know what the graphs look like. It is just the regular graphs kind of flipped over the line y equals x. And we'll go over more on inverses next time. All right, so how do we calculate inverse trig functions? Well, we want to find the angle whose sine, so like sine of theta, equals -1/2. All right, that's what this means. Find the angles whose sine is -1/2. So what I'm going to do is I'm going to draw it. So sine, let's see, I would go back to the first quadrant, but it's positive there. So now I'm going either to the second or the fourth. Sine is also positive in the second, so that means this must be in the fourth quadrant. So there's our right triangle. This is the angle we're trying to find here. This is our theta. All right. Sine is opposite over hypotenuse, so this must be -1. This is 2, so that means it's a 1, 2, square root of 3. And the side of, so that's a 30, 60, 90 triangle, or a pi over 3, pi over 6, pi over 2. So this angle is the 30-degree angle, is pi over 6, and it is negative because we're going backwards. So there's our answer, -pi over 6. All right, arc cosine of 0. So that means what's the angle where cosine will equal to 0? Well, if we get 0 or 1 over here for like cosine, usually we take a look at the graph. It goes up, and then it comes down. Or actually, never mind. That's sine. Sorry, sine. Yeah. Bad, Mr. Robeson. Bad. All right, so cosine looks like that. And hits 0 right there at pi over 2. So our theta here is pi over 2. All right, arctan of square root of 3 means what is the, or tangent of theta is equal to the square root of 3, and we want to know what's the angle theta here. All right, and remember we can also write all of these, I should have mentioned this early, with a -1 in here, like that. This also means arctan, it's the same notation. This would be cosine to the -1 of 0. This would be sine to the -1 of -1/2. All right, so we can also write them all like that, just FYI. All right, so if we want to find this, let's see, it's going to be in the first quadrant because it's positive. Everybody goes back to the first quadrant if they're positive. Tangent, we need two sides, so we'll just put this over 1. So this is the square root of 3. This is 1. So this is a 1, 2 square root of 3 right triangle. All right, this side across from the square root of 3 is the big angle, so that is pi over 3. So we get theta equals pi over 3, always in radians here. All right, we can also do more complicated things like solving equations that involve arctan or arc-trig functions. The way what we do here is we just, well, we get rid of the tan. We get rid of the arctan by taking the tangent of both sides. That's what cancels out arctan. So we're left with 2x minus 3 equals the tangent of pi over 4. All right, the tangent of pi over 4 is 1 square root of 2. It is just 1. So we get this is just 2x minus 3 equals 1. So we add 3, divided by 2, and there we go. Done. Not so bad. All right, now over here, we can take the tangent of the arcsecant of something. What we do is we start off and say, okay, this here is our angle theta. That's what this whole arcsecant is equal to. And then we want to know what is tangent of theta. All right, so what we do is we say, okay, well, secant of theta equals the square root of 5 over 2. All right, that's positive. So now we draw that angle theta, or what that triangle will look like that goes with theta. So secant is, let's see, it's hypotenuse over adjacent. It's cosine flipped over. So that means the adjacent is 2. This is the square root of 5. And let's see, 2 squared plus x squared equals the square root of 5 squared, Pythagorean theorem. So 4 plus x squared equals 5. Subtract the 4. So x is going to equal 1. So the other side here is 1. So now we know what the triangle looks like for theta. We don't actually have to find the value of theta. We just need the triangle because we need to find tangent of theta. So now that we have this triangle, we can just say, okay, well, tangent of theta is opposite over adjacent, so it's 1/2. Done. We never needed to actually find the angle. We just needed to be able to draw the triangle so we could read off the tangent of that triangle. Neat little trick. All right. This is supposed to be you try, so go ahead and pause it and try. All right, so sine of some angle is going to be negative. All students take calculus, so sine's positive in first and second, so that means it must go to the fourth quadrant. So here's our angle theta. All right, it's opposite over hypotenuse, so this is square root of 3 over 2. This side must be 1, 2 square root of 3. The side opposite the square root of 3 is pi over 3. It's the larger side. And it's going down, so it's negative pi over 3. There's our answer. All right, another one of these guys. So we want the tangent of the inverse cosine of 3 over 5, or the arc cosine of 3 over 5. So again, this is going to equal an angle. And then we want to know what's tangent of that angle. All right, if you want to try it, go ahead and pause it and give it a try. So I would say cosine of theta equals 3 over 5. Cosine positive is the first quadrant, just like anybody positive is the first quadrant. Cosine is adjacent over hypotenuse. I know the other side here. It's a 3, 4, 5 right triangle. And now we want to know what's the tangent of that angle. Well, that's opposite over adjacent. So it'd be 4 over 3. All right, we can also deal with this stuff with x's. So we don't even have to have sides. We can have x's. And we can say, okay, well, tangent of theta equals 2x. We could say 2x over 1. And then we want to know what is sine of theta. All right, so the way we do this is, again, we go ahead and we draw our triangle. We'll assume it's in the first quadrant. So here's our theta. We'll get 2x for one side, 1 for the other for adjacent. To get this side, we're doing the Pythagorean theorem. So if you want, you can call this like c. Then you'd have 2x squared plus 1 squared equals c squared. So that'd be 4x squared plus 1 equals c squared. And we can just take the square root. So that means this side over here is just the square root of 4x squared plus 1. All right, we're not going to get a number for an answer. We're going to get a formula. We're going to get a function, really, or an expression with x. So now we want sine of theta. Well, sine is opposite over hypotenuse. And there's our answer. All right, next one. So we got another one working backwards here. We've got sine. Inverse sine is -3/4. So sine of theta is -3/4. And then we want to know what is secant of theta going to be equal to. All right, well, sine negative puts us, let's see, it can't be the second quadrant. It's definitely not the first quadrant. So we're going down to the fourth quadrant. Here's our theta here. We've got -3/4. You might think it's a 3/4/5, but the hypotenuse here is 4. So it's not a 3/4/5. We got to find this other side here. So we'd have, we can call this a if we want. We'd have a squared plus -3 squared, or 3 squared, which is 9, equals 4 squared, which is 16. Subtract the 16, we get a squared equals, or subtract the 9 from 16, we get a squared equals 7. So a is the square root of 7. So that means this side here is just the square root of 7. And now we want to read off the secant. Well, secant is hypotenuse over adjacent. It's cosine flipped over. Hypotenuse is 4. Adjacent is the square root of 7. And there's our answer. All right, so there's our quick little review of inverse trig functions. All right, in the next video, we will go over how to actually take derivatives with inverse trig functions. All right, see you again soon.